I'm going to talk today about Golem. And Golem is a serverless durable execution platform. But we can just say that it's something that runs WebAssembly applications on the server side for now. And instead of trying to sell you Golem or that you need durable execution, I'm just going to talk about why did we choose WebAssembly. And I'm going to give a few examples of how we are taking advantage of WebAssembly's powers. And then I'm going to talk a little bit about a few things that we are doing that might be interesting for you, even if you are not using Golem itself. So let's start with core WebAssembly. So if we think about why we chose core WebAssembly to build Golem on, of course, one of the reasons can be performance. Another is its sandboxing capabilities and the large number of languages that are supporting it. In this talk, I'm only going to focus on the sandboxing capabilities, which is really important, of course, because of safety. That allows us to run applications, multiple applications from multiple users in a single Golem executor process without having to fear about they interfering with each other. But even more importantly, this is the thing that allows us to implement transparent durability. And our durability implementation basically consists of 3 layers, and the most important one is what we call oplog. And we can also have automatic snapshots and something we call custom snapshots. And let me talk about these. So if you are running a WebAssembly program, you have full control of the outside world. It cannot do anything with the outside world that is not done through host functions, right? And everything else that is happening in the program is completely deterministic. And because of these two, we can basically restore an application state by recording everything that is non-deterministic, which is a subset of these host function calls that are interacting with something external. And if we take a look at a very stupid example, which has an add function and a get function, where the add is just generating a random number and adding it to a global state, and the get is just returning this state. If we compile this to WebAssembly and look at the WebAssembly module, we are going to find 5 imported host functions. And among these 5, only the first one is interesting from the non-determinism point of view, the random number generator. The others are used because it was printing something, and it's not important for this discussion. So based on this, we can imagine a very simplified version of our oplog could be something that recording what kind of exported functions we are calling on a worker. Worker is just running a WebAssembly program in Golem. And we are also recording what result was produced by those host functions that are introducing some kind of non-determinism. So to recover the application after this example of calling add twice and then calling get once, it would look like something like an outer loop that does these 3 method or exported function calls on our program. But every time we are running into a random get call, instead of actually generating a new random number, we are just returning what we previously saved. So this way, we can recover the state of the application. And how it looks like in Golems, actually, this is the actual random WASI random implementation. First, we check if we are live. When we are live, then we are running something new, and we are generating, for example, a new random number in this case, calling the underlying WASI implementation, and then persisting the result. But if it was not live, then we are just running this code to recover a previous state of the application, and then we are just reading it from the oplog and returning it without even touching the underlying WASI implementation. And this, of course, cannot recover to a specific instruction in your program. It can only recover to points where you were saving something. And this doesn't really matter, or it can matter. For example, if you are doing something CPU intensive, then it matters because because those are not saved, right? If you are recovering, you are rerunning the whole CPU intensive calculation again and again. But in many of the use cases, this doesn't matter. And when it does matter, then we can optimize this by taking snapshots of the program from time to time. And here I mean taking snapshot of everything, the linear memories, the function tables, the file system associated with this program, the resource states. And this is something we don't have yet. We had a working prototype. It's somewhere in our roadmap. But even until we have it, there is a third possibility, which I'm calling custom snapshotting. And this is basically where it stops being magical, because it unfortunately requires you to implement a custom state save and load function. But if you do so, then we have a very compact representation of your application state. And this also allows arbitrary updates, because if you implement the save in an old version and implement a load function for the same format in a completely rewritten new version, then you can transfer your application state from the old to the new code base. And yeah, the problem is that this requires contribution from the user. It's no longer a transparent durability thing. But we are already using this for supporting these complex updates, and we are planning to take advantage of these functions, or also to optimize the recovery process. So as you can see, restoring a running program is a core feature in Golem, but it's not always necessary. So we have two kinds of workers. As I said, worker is just a running WebAssembly instance. We have durable workers and ephemeral workers. And ephemeral workers are basically stateless and fast. They are just created for serving a single call. And the durable workers are what are long-running and supporting multiple invocations, the things that I was talking about so far. And let's talk about the component model. So we started Golem on the component model from the beginning. We started Golem about 2 years ago using Wasm time 8. And the component model implementation at the time in Wasm time was already almost a year old, but still I think we were very early adopters of the component model. And we always wanted to use it because it enables a lot of features for us, and we were trying not to reinvent the wheel. And basically, Golem workers are nothing else than WebAssembly component model instances. So let's talk about invocation. We wanted to expose a tiled API from our workers, and we wanted to support multiple invocations, and also not just multiple invocations, but having multiple functions to be invoked. And well, this is exactly what a component export is. So there is no real magic here. The Golem invocation API is just a front end for calling anything that your component is exporting. And as I said, Golem can run multiple components and expose their exports to this worker invocation API. But on the other hand, components can also be composed together. And there is this idea that if you are calling a worker from another worker through this worker invocation API, that should behave exactly like if you compose these two components together. It should be just an architectural decision from the user whether you are composing things or you are running the components instances as separate Golem workers. It can be done to be more scalable, to run things in parallel, and so on. And how this is implemented is called Golem's RPC feature, which was first created in Golem, in the Golem Wasm RPC crate, started about a year ago. And at the time, there was no public version or published version of the WRPC solution yet. So we created our own, but we are planning to migrate to it. But in this talk, I'm going to show how our version works. And basically, it consists of two things: a Wasm RPC host interface and something that we call the stub generator. And the host interface is a with resource, which has a constructor which selects what worker we are trying to communicate with. And it also, And it also has a few functions that are quite dynamic. They are taking the invoked function's name as a string, and they are taking the list of parameters as something that we call with value, and also the result value is a with value, where with value is just a way to describe an arbitrary component model value within the component model. And of course, this host interface is implemented by Golem. Any Golem component can import it and use it to invoke another worker with it. But it is very hard to use because you have to construct these with values from your real values, and it's not type safe at all. You have to provide function names as strings, and also the list of with values is dynamic, and so on. So it was never intended to be used by hand. That's why we have the other half of this solution, which is called the stub generator. And let's see an example of that. So if you have worker A that is trying to call worker B, and worker A is just exporting a function that we can call, worker B is exporting some kind of counter interface with an increment and the get function. So we could have the first idea of just importing the counter interface into the caller component, and that would make it a regular function call. If we generate bindings, then we have a statically typed way to call these methods. And we can say that let Golem solve this for us. It knows what components we are running. It can figure this out. But it cannot figure it out because in this setup, we would have no way to say which worker we are targeting. If we would only have ephemeral workers, then this would be enough and it would work. But because we have durable workers, we have to exactly specify who we are targeting with our RPC call. So the idea is that we are generating a third with file package that is the client package of the thing that we are calling. And that is derived from the original with package by wrapping everything in a resource and adding a constructor that allows you to specify which worker you want to talk to. And this way we have an answer to this question. And then, we have this generated stub client with file. But what implements it? And originally, we were generating an implementation for it in Rust and compiled it to Wasm, and then composed this compiled component with the caller component. And by that, we eliminated the dependency on the generated client stub. And it was only depending on the generic dynamic host interface that Golem implements. We are treating this deprecated now because we have another way where you are just marking all these generated stub interfaces, record their names in some kind of metadata, and then do dynamic linking, which was actually inspired by looking at WRPC. And this means that when you are instantiating the component, it's going to complain about these generated with packages because that is not implemented in our host. And then these missing imports can be checked whether they are marked in the metadata as being RPC clients. And then we can just dynamically link them to an implementation that does the actual RPC calls under the hood. And this is a very generic idea that we can use for many other things. For example, you can imagine having an open API, or gRPC, SMIC, GraphQL, whatever client with generated from these specifications. And then just generate either a composable client component that implements this with, or you can use the trick to directly support this through dynamic linking within the executor. And it doesn't even have to be just clients. It can be, for example, typed configurations is also a good example where you can specify a set of configuration properties and then generate a with file from that, so you have a statically typed way in your program to access these properties. And then we can use the dynamic linking trick again to calculate the values for these properties runtime. And invocations in Golem are processed sequentially at the moment, which is a limitation because if you're doing something long-running and trying to invoke the same worker again, then that invocation will wait until the previous invocation is finished. I think it's also a feature because it makes things easier to think about. But the good news is that with the arrival of the async feature in WASI Preview 3, this is going to be a user choice. And as I already said, the worker-to-worker communication is somewhat equivalent to component composition. And in this case, it means that allowing these interleaving external invocations is basically the same decision as whether you are export or importing a component interface as a synchronous or an asynchronous set of functions. And once we have this, we can do also something that we call persistent sockets, where you can imagine 2 or more clients that are connecting through WebSocket to some kind of API gateway. And then the API gateway is talking to a Golem worker through RPC. And we can represent these connected clients as remote resources through this RPC connection. And we can use the Preview 3 stream types to model the streaming nature of the WebSocket. And then, this is something that has a few requirements. We need RPC with first-class resource support, so you can send over this remote resource from the API gateway to the worker representing the connections. Our RPC is not completely satisfying this, but migrating to WRPC will solve this. And of course, we need the new streams, and we need to support these interleaved invocations. Otherwise, a new incoming connection wouldn't be able to be added to your running worker that is already handling these streams. And another use case that we have for all these component model features like resources and composition and everything is answering the question how to constrain worker-to-worker communication. And one idea is that we could model permits as with resources that you cannot create. You can just derive more strict ones, and you have some root permit associated with your worker that you can get with a host function, for example. And then RPC calls can require you to actually pass a handle to this resource and check in the host whether you have permissions to do this call. And they can, by having resources as a first-class thing over RPC, you can also share these resource handles with other workers and pass capabilities to them with that. And we also planning to actually make Wasm RPC or WRPC the primary protocol of Golem. And together with this permission model, it will allow any worker to manipulate Golem itself in a very nice way. And yeah, of course, we are also very much depending on WASI itself. We always wanted Golem to, always said that Golem should run any kind of program automatically in a durable way. Of course, the any is something that you can compile to a WebAssembly component. But we never wanted to create custom host APIs for things that are having a WASI interface already. So we ended up right now supporting basically everything that is implemented in Wasm time for WASI. And we are also implementing a few additional interfaces like blob store and key value store and the logging interface. We have our own relational database access package, which I will talk a little bit more about. And there are a few Golem-specific packages, but they are completely optional. If you don't want to customize durability features and stuff like that, you don't have to use them. So what can we contribute, or what are the things that might be useful for you even if you are not using Golem? I will talk about something that we call rib, and another thing that we call app manifest, and this database with package thing. And I'm not going to talk about, but most of Golem is open source, and we are publishing Rust rates and so on, so you can check out the actual code or use things that we are having. And also, we are treating the JavaScript, TypeScript ecosystem is very important to us. So we are heavily testing these things in the ecosystem, like the Starling Monkey and Componentize.js and all those things, and reporting issues, fixing things if we can. And also, we publish the Scala.js with binding generator. So if you want to use Scala for some reason to create components, then you can. So rib is, what is rib? Rib is a scripting language to work with Golem components. And it was primarily created for describing APIs. For example, in this snippet, we have a few lines of code that is extracting things from an HTTP request body. And then we are creating some new data types. We are selecting a worker that we want to call, and then we are calling an exported function on that worker and returning a HTTP response. So basically, Ruby is something that enables you to call WebAssembly components, and it has access to some kind of context, in this case, an HTTP request. And the language itself is statically typed with type inference. The types are exactly the component model types, so there is no any mapping necessary. The value syntax is just the WebAssembly value encoding itself. It supports things like pattern matching. It supports list comprehensions and reduce, and string interpolation. It has first-class support for selecting a worker and invoking methods on it, and creating with resources and invoking methods on that. And it has some kind of with package interface inference, so you don't always have to specify this fully qualified namespace name version interface, whatever path of accessing a type. But there is no need to only use this for API mappings. For example, even internally, we could use this for testing. We are planning to create a REPL to interact with workers, even having a prototype of that already. And it doesn't even have to be Golem specific. It could be treated like a general purpose scripting language for WebAssembly components, or it could be a scripting language for anything that has a WRPC interface. And yeah, this is implemented in Rust, and it's published, and it's ready to be used, although it has some Golem-specific dependencies at the moment, but we are planning to get rid of those. So what is the app manifest? It's a YAML file, not very surprisingly. A YAML file that is describing one or more Golem components and their relationships, for example, if they are communicating with this RPC method. And it is a build tool as well that builds and composes components. It's fully customizable, and Golem has built-in templates for a lot of languages. And yeah, so basically it's a build tool that understands things like with directories and this stub generation that I was talking about, and it knows how to compose components. And let's just see a quick example. So if we create a new Golem application with our CLI tool and add 3 new components to it in 3 different languages, Rust, TypeScript, and Moonbit, and then we are just typing Golem app build, what's happening is that it will assemble with depth directories from various sources. It's doing cargo component build for the Rust component. It's doing the component SJS thing for the TypeScript one. It's doing Moon build, and then the additional necessary steps for the Moonbit one. And of course, it also does caching and up-to-date checks and everything that you would expect. And then if we add dependencies in this, so we can describe relationships like the TypeScript component is depending on the Rust component, and the Moonbit one is depending on the TypeScript one. And we are just typing Golem app build again. Then it's going to do all the things that has to be done. It generates these client stubs. It auto imports them in the places where it has to be. It generates and builds these files and compose everything that has to be composed. And this is very Golem specific at the moment, but it doesn't necessarily has to be. It could be a general purpose glue tool for guest language tooling if we want to. And the final thing here is that, as I said, we want to build on standard interfaces, but sometimes we cannot wait for them. So that's why we, for example, created the Golem RDBMS with package. It's a with package for working with Postgres and MySQL. And it's not Golem specific at all. It's just was created by us. And it's already implemented in Golem, so it can also be tried out. And we would be happy to cooperate in any way to make this one of the standard interfaces, or at least inspire the standard interface with it. And finally, a few things, or I could say a wish list. Better support for with evolution is one thing. Code first with tooling is another. And also some kind of solution for JavaScript and Python components being so big. I'm not sure what exactly the solution will be, but that is something that would be nice to be solved in the near future. And also, if Wasm time would support that snapshotting that I was talking about, that would be nice, because then I wouldn't have to figure out how to do it properly. And better support for with evolution. What do I mean by that? We already have this semantic versioning support in Wasm time, which is really nice. It's not working in some other places, though. And even if it would work, we don't really have an answer, I think, for how to do data evolution with WIT, like adding new variant keys or new optional record fields and stuff like that. And if people are starting to use WRPC for even communication between things, I think we should have an answer for these questions. And finally, code first with tooling. We are in the ecosystem very much specification first at the moment. We are always writing these with files first and generating everything from them, which is good. But we could also support a code first approach. And of course, that could be done in two ways. There could be native component model support in languages. But even if we don't have that, we could have language-specific libraries, for example, Rust macros and so on, that are taking your interface and data type definitions in your chosen language and just figuring out the WIT packages from that. And then the users do not have to learn WIT or understand all these special things. And that was it. So thank you for attending. Any questions? Yes?
I wonder, is Golem actually sort of a actor framework on steroids?
It can be seen as an actor framework, yes. It has similar semantics, yes. OK, thank you.